One thing that we can also use that we can find is useful is going to be an offshoot of the slope formula. Remember slope? M equals y2 over y1, or y2 minus y1 over x squared minus, or x2 minus x1. Sorry about that. Let me do some algebra here. Let's multiply both sides by x2 minus x1. And then let me just kind of reverse it where I have y2 minus y1 equals m times x2 minus x1. This form right here is something we call point slope form, or the point slope form of a line. And it's useful because if we're given some other types of information, that this is an avenue or a tool that we might be able to use. So let's say, for example, and let me rewrite it up here, y2 minus y1 equals m times x2 minus x1. Let's say that I'm given some information. For example, I'm given where we have a slope equals 4, and I know that the line with this slope passes to the point -1 and 3. I'm given two pieces of information, a point and a slope. And based on that, we can come up with the equation of the line. So let me show you how we do that. First, let's designate this point as x1 and y1 and just plug things in. So I will have y2 minus 3 equals m, whoops, we know what m is now, 4 times x2 minus 1. And I can also drop the subscripts because there's only one set of y and x that's left, y2 and x2. So I can just as easily write it y minus 3 equals 4 times x minus 1. Let's do some algebra. So I'm going to add 3 to both sides, and I'm going to multiply that side out. 4x minus 4 plus this 3, and then lastly y equals 4x minus 1. So there's an equation that happens to be written in slope-intercept form of this particular line that has a slope of 4 and goes to the point -1 and 3. And it's a great tool. We can graph this fairly easy.